can always go back and watch it later. Okay, so Anna, you asked for this one. How do we begin?
Well, I forgot that you put the zeros on both sides.
Yeah.
Yeah, so that threw me off a little bit. But I copied your notes because I honestly forgot, and I kind of.
It's kind of tough to follow. I mean, I wrote what I was doing. So guys, when you're doing Gauss-Jordan, and Julie, I definitely want you to hear this too. When you're doing Gauss-Jordan, I think everybody's first move is to make this number a 0. That's a good first step, is just make that a 0. So what are we going to do?
Multiply by -3.
Yep, so then I multiply by -3, that's -6, and then -27, and then, negative something. Yeah, great, -84. So now I can go ahead and make that, I keep the top row, but then I have the 0, the -23, -92.
Yes.
Okay. Okay, great. Now, our next goal is to turn that into a 0. But you can probably make life easier for yourself if you take care of this first.
Because you can actually divide that.
Yeah, you can divide that by -23. So, and again, that's just making our life easier. So now, whoops, 6, 4, -8. But I'm going to go ahead and divide those through. So that's actually 1, and that's actually 3.
4.
Oh, 4. Yeah, so that's actually 4. Oh, well, yeah, so that's just simplified. So now I have 0, 1, 4. Okay, so now how do I turn that into a 0?
So -4 on the bottom.
Yeah, so now I multiply the whole bottom row by -4. So that's actually 0, -4, -16. And now I add that into the top row. And then that would give me 6, 0, and -24. Is that correct? Yeah. So really, again, your main goal is just to get those zeros. Because then as a byproduct, it's simple to turn those into 1s by just dividing through. So now I'll divide through by 6, and that gives me a 1 and a -4. And so now I know that I have 1, 0, -4, and 0, 1, 4. So Julie, did you see all that one? Okay. So yeah, that's our goal, is to get those zeros. I'm happy to do another one. I know that you and Nick were working something out, and I'm glad that you helped each other, but I do want you to see one of these through, because you were specifically asked about Gauss-Jordan. So we'll do one more of those.
So in the guess book, we'll have the 2 zeros on top, and
Yep.
the other one will be just those straight ones.
Yep, I want to see Gauss-Jordan form. I want to see 1s and then 0s otherwise. Yep, because then that's the answer, right? This is your x equals, and that's your y equals. So x equals -4, and y equals 4, and so your coordinate is -4, 4. All right? Okay, so the other Gauss-Jordan form.
And that means where they intersect.
Yep, that's the point of intersection of the two equations. If you graph them, they would intersect there.
That's all the work we need to show, right?
Yep, right there.
I know in practice test you did that. You had like the replace.
I didn't write, yeah, you don't have to do that. Yeah, I only did that to help you guys to actually follow what I was doing, because otherwise it appears mysterious a little bit. Okay, so this next one, we might as well do this one because you might have one like it. So let's see. Linda invests $25,000 for the year. And so that was our first equation. So let's go ahead and jot down, before I make the matrix, I'm going to say she invests 3 different amounts of money into a bank, and they all add up to $25,000, right? So if you all want to work this out together, I think that would make more sense than just watching, or you can watch, but you'll get more out of it, I think, if you copy it along. So that's one equation. The other equation is that they say that parts invested at 5%, 6%, 8%, and that total interest is $1,600. So we have 5% on the first account, and what? 6% on the second account.
And 8%.
Yeah, and then 8% on the last account. And anytime you multiply a percent times an amount, that's interest. So the total amount of interest was $1,600. And then the third equation is the best equation. It says the income from the 5 and 6% is the same as the income from the 8%. So you know that both of them, since it's $1,600 total, the first two accounts have $800 in interest, and the 8% has $800 in interest. Because you're taking that interest and splitting it into half. So should we say that the 5 and 6% equals 800, or just the 8% equals 800? Just the 8% equals 800. So now I know that this of just the 0.08z, that alone should equal 800. And I'll put zeros right there. Talk about fun. So because they told us that, we now have a really good start to our equation. I'm sorry, our matrix. This better. We definitely keep the 1, 1, 1, 25,000. What do I do to the next equation? Yeah, multiply the whole thing by 100, right? Because that way I have 5, 6, 8, and then 160,000. Yeah. And then the bottom row, nice and convenient. Again, you'll multiply times 100. And that way you just have 8 and 80,000. And those are zeros. So in terms of planning, remember your goal is to get zeros below and zeros above. So look, we already have 2 zeros below. So Julie, I'm definitely talking to you. Well, I'm talking to everybody. But how do I turn now this one into a 0? Because we want to keep this diagonal of numbers and turn everything else into a 0. What would I multiply this top row by so that I could add it to the 5 and get 0?
-5.
Yes, I'm going to multiply the whole top row by -5. And that's going to give me -5, -5, -5, and -125,000. So then I add that to that middle row, and what happens is you keep the top row, which was that, and now I'm going to add my new numbers to that middle row and see what I get. So -5 and 5 is 0, -5 and 6 is 1, isn't that convenient? -5 and 8 is 3, and then -125,000 and 160,000 is what, 35,000? Great. And now, should we keep the bottom row or do something to it real quick? Yeah, might as well divide out the 8, right? So I'm going to multiply that whole row by 8, or 1/8. So that's 0, 0, 1, 10,000. So this is great. We've got our diagonal of 1s, which is super convenient. It's so easy to cancel out other numbers when you have a 1 in the diagonal because you can multiply it by anything that you need to get rid of it. So what should we get rid of next? Jason? Yeah, might as well get rid of the 3 and just start working your way back. In fact, I think that it might even be necessary that you do have to work your way that way. So now I'm going to multiply the whole bottom equation by what, Julie? I want to get rid of that positive 3. Well, no. If you did divide this row by 3, you would turn this into a 1. But we don't want it to be a 1. We want it to be a 0. So you have to multiply this row by something to add it into it. Yeah, so -3. So that gives us 0, 0, -3, -30,000. And then when I add it into itself, my bottom row stays as 0, 0, 1, 10,000. For Z, it's 10,000. And now this next row is 0, 1, 0, and then 5,000. And folks, to be honest, do we now have the answer to the problem? Mm-hmm. We kind of do, because now we know that Z equals 10,000 and Y equals 5,000. And you know that all 3 accounts add up to 25,000. So now we can just infer, like, well, that adds up to 15,000, and the total is 25,000, so the last one's 10,000. Now, are we done making this Gauss-Jordan form? No, technically you would need to do 2 more zeros, right? So you'd multiply this row by -1, make that a 0, and then you'd multiply this row by -1 and add it to that to make that one a 0.
But do you want us to, or do we, can we just stop at that?
Well, that's a really good question. I'd like to have at least one problem on the test where you get that solid result and you're like, bam, Gauss-Jordan dropped the eraser, you know? So I think that you should proceed. Okay, with echelon form, I was like, okay, you don't have to turn the diagonal to 1s because I get it. But with this, it's Gauss-Jordan form. So I think we should need to finish this and turn it into Gauss-Jordan form to make it Gauss-Jordan form. Yeah. Okay, well, really nice. Now, how many times did we have to redraw this matrix? Just 1, 2, 3 times. Well, I'm sorry, we're not done with the problem. We have to finish. But it would be 4 or 5 times total. All right, well, great, folks. That's Gauss-Jordan form. Now, during the test, you're allowed to come up and ask me questions, and I'll choose whether or not to answer you. But if you do ask about Gauss-Jordan form, probably the only thing I'm going to say to you is, did you finish turning everything into zeros? Right? Because that's ultimately what we should have is all those zeros so that you can read your answers. So just keep in mind, that's your goal, that's your mantra, is you're actually creating zeros. Okay, who'd like to ask another question from chapter 2?
Chapter 253.
What? 153.
No, we're doing it.
Oh yeah, the practice test. So number 12 and 13 we should talk about. On number 12, I don't think it would make any sense to use your calculator. You'd probably just do that by hand. And that's what I'd like to see. Number 13, I can see why you'd want to check your work with your calculator. But I think I'd like to see you do it by hand. Okay. Number 14. Let's review how to do 14 and 15, because I think you'll definitely have two problems like these. These are the problems where you have to do it on your calculator, right? Because I'm actually testing your ability to use your calculator. So, should we review this? You guys want to see how to do it? We can at least review how to set it up. So when you set up your matrix, it's -2, -6. I'm sorry, -2. Yeah, -6 and -2. And then 2, -1, and -5. So what's what? Where's the A matrix and where's the B matrix?
A is gonna be remat.
Yeah, that's your A matrix, and then this is your B matrix. And so once you type those into your calculator, on your calculator, all you would need to do is literally type in matrix A inverse times matrix B. And that's going to give you the answer to the whole system.
Mr. G, could we review a little bit of number 13 after we do this?
Oh, how to do the multiplication? Sure. Okay, so that is your whole procedure for number 14. You type it in the calculator, and I think everyone knows where that -1, yeah, we were all here when we did the calculator skills, okay. All right, well then, same thing goes for number 15. Number 15, you have a larger matrix. How do we set that up? Because they only gave us matrix A. What's matrix B?
It's gonna be, fill this order as the numbers that give us in the next line. Yep.
Yeah, 72, 48, and 63. And notice flour would be the top number. And then sugar would be the second number. And then eggs would be the third number. So it should go 72, 48, 63. That would be your B matrix. Right, and again, you just type it in your calculator and it's awesome. Okay, so we're gonna do 13, and what else, Anna?
I have a number 12.
Okay.
It says, can we subtract?
Well, that's a really interesting point. You can think about it in a lot of ways, but read it. Anna, read the question to us.
Find the matrix that is increased between cell by each cell for each type of insurance from July to August.
Yeah, from July to August. So really what that means is you're going to give a matrix that gives the change. So you can just look at each entry. How did it change from July to August?
Oh,
Increase
3,000.
Plus 3,000. So you can just look at it and say to yourself, well, that was a plus 3,000. Whereas, how did it change from July to August here?
Minus 1,000.
Minus 1,000. So now what's the answer to Anna's original question? Do you subtract top minus bottom or bottom minus top? The answer, like looking again at the first entry, the answer better be 3,000.
Oh, okay.
So it's bottom minus top. So Anna, for that particular problem, it is bottom minus top. Well, what if it doesn't display that way? What if it gives you them left and right? Then it would be right minus left, right? But really, what are we asking? And yeah, the change, you could say August minus July, right? That would be a little more accurate. After minus before, right? Now we're getting a little more general. It's the after minus the before. You're looking for change. So you always do the after and then subtract the before. That's the definition of change. What's that, Shmai? Oh, I think both of those are on there. There's something similar anyway. Okay, and now, oh yeah, as far as actual multiplication goes. So when you multiply, yeah, I'm happy to model this again. So we're going to multiply the 4, 6, 1, 5, 3, 1, and the 3, 3, 1. And we're going to multiply that times 3, 2, 3, 4, 2, 2. Great. In order to do any multiplication, you have to first analyze the size. So we know that the size is 3 by 3 times 3 by 2 because it's rows by columns. So your size is always rows by columns. So since the middle two numbers match, we know we can multiply. And so the result is going to be a 3 by 2. So the result will be also a 3 by 2. So here's, I know we said this before, but let's just look at it again, fresh. How do I find this number? That number is in the first row, and it's also in the first column. So what you would say to yourself is, I want the number in the first row and the first column. So you come here to find the first row, and you come here to find the first column. And then you multiply term by term by term and add them all together. So 4 times 3 is 12, plus 6 times 3 is 18, plus 1 times 2 is 2. So 12, 18, and 2. 12 plus 18 plus 2. 12 plus 18 is 30, plus 2 is 32. And that's how you want to think about it, using your fingers. Like, this is important technology. First row, first column, first row, first column. Term by term by term. So if I want this entry, where do I look? I do it here first. I would look in which row? The first row, and then which column?
Second.
The second column. So I go to the first row, second column. 4 times 2, 6 times 4, 1 times 2. That's 8, 24, and 2. 8 and 24 is 32, plus 2 is 34. It's tough to do all that in your head, folks.
So for the next one, we're gonna use the second row, and then the first column.
Yeah, second row, first column. So I go to my second row, first column, and you might just choose to write it all down. 5 times 3, 3 times 3, 1 times 2. So 5 times 3, 3 times 3, 1 by 2. So that would be 15 plus 9 plus 2, which is 24 plus 2, which is 26. And it would look like that.
Perfect. Thank you.
Who asked about multiplication? Oh, you did.
Mm-hmm.
Yeah, so did that. Okay. All right. So that was the matrix inversion. I took this question off the test. Didn't we already say cross it out? Okay, so chapter 17. Which ones would you like to see in chapter 17? We'll definitely do the last few. Yeah, we'll do the last few. So number 17, you're just plugging numbers in. Number 18 and number 19, we're finding first partials. So let's review how to do a first partial.
And we would call it the function, the first partial derivative with respect to x. Is that how you say it?
Yeah, you'd say the partial derivative of f with respect to x. So we have a function f of x comma y equals 4x cubed minus 2xy minus y. And we would like to take the partial derivative with respect to x. And so that means x is your variable, and everything else comes along for the ride, right? X is the variable, everything else comes along for the ride. So to take the derivative of 4x cubed, 12x squared. Now, here's my variable x. If you just took the derivative, and again, I really like this method. Ignore the y temporarily. What's the derivative of negative 2x?
2.
Just negative 2. And so the y comes along for the ride. That's it. I really recommend you just cover the other variable with your finger, do the derivative of what you know, and then the y comes along. So like here, this is the number what? Negative 1. And what's the derivative of negative 1? 0. So 0, y comes along for the ride, but it still does 0, so it's 0, so there's nothing there. All right, so that's the first partial of that one. And there's nothing else you have to do for that problem. It's just find the partial derivative. So what about this next one that looks like a word problem where it says things about manufacturing and cost?
No, we have to find
You have to plug it in.
when
Oh.
x is 1 and y equals negative 2.
Oh, sorry, you do have to do something else. Yeah, you have to plug in those numbers. So you're saying, okay, I'm finding the partial derivative at the coordinate 1, negative 2. So I'm plugging in 1, negative 2. So 12 times 1 squared minus 2 times y. So you carefully plug in those numbers. And so that'd be 12 plus 4, which is 16.
What does that 16 represent?
16 represents, because this is a derivative, what does the first derivative always represent? Slope. It represents the slope in which direction? In the x direction. So, for instance, if this is the x direction and this is the y direction, in the x direction, the slope is 16. Yeah. If it had been a negative 16, it would have been negative 16. Or if it had been a partial in the y direction, it would have been in that direction of the y, or that direction of the y.
Okay.
So yeah, that's what you're saying. You're saying at that particular coordinate, the slope in the x direction. Because we're always looking at mountains, right? We're looking at a three-dimensional shape, something that has three-dimensional shape. Okay, great question. So this manufacturing one, what do we do there?
For number 19.
Same thing, right? Oh, no, it's not 17. Sorry. Yeah, 19. Same exact question. It's just asking you to take the partial derivative with respect to x and then plug in 3 and 4. Now this has a different meaning. Lorena asked, what's the meaning of it? That's interesting. Let's find out. So m of x comma y is equal to 10x squared plus 50y squared minus 9xy. So what's the derivative with respect to x? Carmen, do it for us. What's the derivative with respect to x? I'm on number 19. $20x. Oh yeah. What was the last thing you said? Minus what? Yeah, minus 9y. So she already did the 20x, and then this just goes away, because if you ignore the y squared, the derivative of 50 is nothing. And then over here, ignore the y, the derivative of negative 9x is just negative 9, and then the y comes along to the left. Okay, thank you, Carmen. So now, folks, we plug in the number. 3, 4, right? So that would be 20 times 3 minus 9 times 4, which is 60 minus 36, which is 24. So now 24, it still means slope. It still means slope. But what we're looking at is the slope in the direction of x. And what does the x variable represent? The
Cost of material.
Yeah, the cost of materials. So when you let the cost be $3 and the cost of labor be $4, then we're saying that the slope in the x direction, the cost of materials, is changing by a rate of $24 per unit. So right now, this slope is saying, because it's the slope of the x direction, the cost of materials is changing by $24 for every additional unit that you choose to manufacture. Actually, no, it's $24 for every bump in price. Yeah, because if you change the cost. Oh, no, here we go. M is the manufacturing cost. Yeah, this makes sense. If you change the cost of materials by 1 unit, you change the manufacturing cost by $24. Yeah, so the M is the actual manufacturing cost. So you're changing the manufacturing cost by $24 for every $1 change you make in the cost of materials. Now this is an interesting question, and because it's fun to think about what these things mean. I'm not asking you to label that, to say what that is, but that is in fact what we're doing. We're looking at the change in the manufacturing cost with respect to the change in the materials cost. Does that make sense? Because we're doing the derivative of M, and M is manufacturing cost. But we're taking it with respect to X, which is the materials cost. And so since the derivative was 24, that means the slope, the rate of change, is that the manufacturing cost will change by $24 for every $1 change you make in the cost of materials. Okay, well anyway, we don't have to go into that much detail. Okay, which partial would you like to see? We're going to have to do partials in the remaining problems. Should we just move ahead? Okay, now what about 21? We have to do this in the Lagrange and determinant problems, but should we do it by itself once?
Yeah.
Yeah, let's do it by itself once. Okay, everybody ready? We're all looking at the same thing?
Yes.
Yeah, let's all do it together, because literally you're about to do this. So we have a function, which is x squared plus xy plus y squared minus 3x plus 2. And the first thing we want to do is take the partial with respect to x and set it equal to 0. So what's the partial with respect to x, Shemai? Yeah, 2x Yep, if you ignore the y, the derivative of 1x is just 1, so that's 1y. The derivative of this, 0, the derivative of this, -3, and the derivative of that, 0. Okay, great. So folks, there's our first equation. We took the partial and set it equal to 0. So now how about the next partial? The partial with respect to y. I'd like to do that one for us. Yeah? Go ahead and take the derivative with respect to y. That's a 0. That'll be 1x, because the x comes along to the right. And then the derivative of y squared, 2y. And then the derivative of this and this, 0. Okay, well great, that's there. So folks, and what?
So we got that far.
Yeah, okay, so remember it says find the values so that they're both equal to 0. So now you take this one, set it equal to 0. You take this one and set it equal to 0. And those are just two equations that you can solve any way you like. Two equations you can solve any way. So I'm going to stack them on top of each other. 2x plus 1y, I'm going to move the 3 over, equals 3. And then 1x plus 2y equals 0. And you can feel free to solve it however you like. Wait, Shemai, do you see how I moved the 3 over?
Oh,
I just added 3 to both sides. I should show that. Plus 3 plus 3. So how do you want to solve this? Do you want to do elimination? Do you want to do substitution? You can do a matrix. In fact, honestly, folks, you can plug this into your calculator. 2, 1, 1, 2 as your A, and then 3, 0 as your B. And then you can just type in A inverse B. Does anyone like that idea?
yes.
You can just straight up do that on your calculator.
So it has to be the inverse one on that problem.
Yeah, A inverse B.
So we multiply, right?
Yep, multiply A inverse times B.
But it's like
But honestly, folks, you could probably do elimination just as easy. Because I could just multiply this equation times -2. So then I've got -2, -4, and 0. And when I add those two equations together, I get -3y equals 3. And then I immediately get y equals -1. And then I go back and I solve for x.
So for that, there's no way that you like want us to solve it.
You can do it any way you like. Which is why I'm probably thinking the matrix, because you just type that in your equation, you get it. But I mean, substitution was pretty easy, and so is this. I mean, now I have 1x plus 2y equals 0, so I can plug in the -1 for y. And now I know that x minus 2 equals 0, so x equals 2. So, I don't know. If you want to do it by hand, you can do it by hand. Now, those are the values where both of those slopes are 0. So that means that if you went to the coordinate 2, -1, that's your critical point. That's a critical point where both of the slopes are 0 in both the x direction and the y direction. So that means that that point in space is either a minimum space where something comes down and bottoms out, or it's the top of a mountain, or that means it's a saddle. Right? So you don't know yet. All you know for sure is that this is called a critical point. A critical point is whenever both partials are equal to 0. And there's only one critical point. So then you would move forward and do the next process of this thing to find out, is it, what is it? Questions about that process? Carmen? Questions about that one? Julie?
Actually,
Okay, super. All right, so we're down to just doing this determinant problem in the Lagrange multiplier. Lagrange. So now I give you a full page of space for this. So when you get your test, it's 5 pages long, but that's because I gave you a full page for 2 problems. So it's not as long as you think. Yeah.
Will there be one or two?
1.
Okay.
Yeah, there's one determinant question and one Lagrange problem, but they're both worth 1 billion points. Yeah.
Sounds right there.
Anna?
If we show our work and we go off, like we got the wrong answer, we check and we'll try for the
Oh, of course, of course. I analyze your work. I analyze it and see where you went right and where you went wrong, and then I give you feedback.
I completely mind. I just
Yeah, no problem. Okay. So folks, let's do it. I think I'll erase this. Well, I'll start over here. So where do we do first? You know, come to think of it, I don't see steps up here. So we should write down some steps. And in fact, what I'm going to do is I'm going to write the steps here. So for the determinant problem, what is our first step?
Find the derivatives with respect to x.
Yeah, we need to find both partials
Mhm.
and set them both equal to 0 to find the critical point. So I'm going to write very nicely, find critical points by setting f little x equal to 0 and f little y equal to 0.
That's gonna give us the AB that the
Yeah.
determinant.
Yep, find the critical points A, B by setting them both equal to 0. Now that's what we just did. That's literally what we just did. We took a partial with respect to x, a partial with respect to y. We got two equations, set them both equal to 0, and then solve them however you like. So that's a long process in and of itself, right? That's a long process in and of itself. Okay, then what do you do with that critical point? Now to even begin this problem of plugging in your critical points A, B, you would need to find fxx, fyy, and fxy. So that would be our second step. Find f little xx with respect to xy, and then f little yy with respect to xy. I'm sorry, and then f with respect to xy. There we go. So you just have to go find all those second derivatives, your second derivatives. And then once you have your critical point A, B, and all three of those second partials, what do? You just plug it in. Plug your critical points A, B into the determinant formula, which is D equals fxx of AB times fyy of AB minus fxy of AB squared. Right? All right, so shall we do it? Let's do it. Did those steps look clear? All right. So I'll call on all of you to help out. Okay. So C of xy is 10x squared plus 5y squared minus 240x minus 360y plus 18,000. Okay. Now, Lorena and Daisy, I don't want to leave you behind on this one. Like, I want everybody to see it because we're about to do it too. Is that okay that I interrupted you?
Yeah.
Okay, because I want you guys to follow along. All right, so everybody, what's our first step?
Find the points.
Yeah, find the critical points by. Yeah, take both partials and set them both equal to 0. First partial, so with respect to x, and let's see, I already called on Carmen, and I think I called on Nick. Go ahead and do the derivative with respect to x.
That would be 20x.
Yeah.
That's 0.
That's 0.
That's minus 240.
Okay.
And 0, 0.
Okay, perfect. So there we have our first equation equal to 0. I'm so excited, it's easy. I'm going to go ahead and solve it. 20x equals 240, and then x equals what? 12. All right, great. So that's my A in my AB. Okay, Daisy, let's find the partial derivative with respect to y.
10y.
Oh, okay, yeah, that one's 0.
That's 0.
Okay, 10y,
0.
0. And minus 360, 0. Okay, that one's also so easy. I'm going to set it equal to 0. Go ahead and solve. 10y equals 360, and therefore y equals 36. So, what's what?
Our critical point is 1236.
Yes, exactly. So our AB, which I'm just going to write down here for my knowledge, is 1236. So that's the point we're interested in. Okay, so that was phase 1. We just did both partials, set them both equal to 0, solve for our critical point. What's phase 2?
Find the second.
You know, we find all those second partials. So xx and then yy and then xy. So I'm going to do xx first. If you take this derivative with respect to x, Shemaya, what's this derivative with respect to x? And what's the derivative of 20x? 20, and the derivative of 240? Yeah, it's 0. So, yeah, the second partial of with respect to x twice was just 20. Now, what about the second partial with respect to y? Go ahead, Shemaya, one more. Take this derivative with respect to y. And 0. So that one's just 10. But now I need to know my cxy. So Anna, what's my derivative of this one with respect to y? There are no y variables, so that's just 0. So now we have our 3 second partials, and now we're going to plug it all into D. Yeah.
Say CXY, we don't want to look at the X portion of that one, because it's that one.
Yeah, to do the cxy, you look at the x derivative, and then you do the y also. So this means first take the x derivative, then take the y derivative. So this was me taking first the x derivative, and now I then take the derivative of this with respect to y.
Oh.
You go in that order. Okay. All right, so we have our 3 partials. Now we start plugging everything into D. So I'm going to write the equation for D first. I hope you all do as well. You write cxx with respect to 1236. And then that's times cyy with respect to 1236. And then minus cxy with respect to 1236. Square, yeah. Okay, so then what's cxx with respect to 1236? Well,
20.
yeah, just 20. There's nowhere to plug in the numbers, so that's just 20. And then this one, cyy, there's nowhere to plug in the numbers, so that's just 10. And that we already knew was 0 squared. And so our answer is 200. Now this will be on your paper. So, oh, and I think we know everything now. So D is 200, which means that it's greater than 0, which they both are. And fxx is 20, which is greater than 0. So that was a minimum. So then you would just conclude the problem by saying, critical point, 1236 is a minimum. Okay? And I will leave those steps up there.
And you find out saddle too?
And then what?
Saddle?
Oh, it wasn't a saddle.
No, I'm saying, but then we will look if it's a saddle as well.
Oh yeah, if it was a saddle, if the D turned out to be negative, you'd say it's a saddle. Then if D turned out to be 0, you'd say, oh, it's inconclusive. We have no idea. Check your graphing calculator. Okay. Number 23 would be similar, using using the determinant. But I think in the interest of time, I think we're okay not doing 23. Oh my gosh.
I just have a quick question on 23.
What time does the photocopy center close? 6? I totally forgot to go pick up the test. I'm gonna go right now to see if they're there. Boy, wouldn't that be a trick? I'll be right back.
Then my wish would have came true. We don't have to. See, y'all get to asking him more questions. 6.
It's not.
Ya que sacas lo
I'm
que
not
es la
ready.
ley, cuando sacas el money,
I kinda.
so D is positive, right? So when you look at that, you know that these are positive numbers. So you start looking at your options. And what I usually do, we have to base that cross. So I'm like, okay, D is not 0, so I know it's not going to be this option. D is not less than 0, so that's not going to be an option. So now it's between these two options.
Don't want to worry about that one.
The second
Yeah.
is parameter that you use to figure out which is your second. Your second one. So CXX is less than 0 or greater than 0, meaning is it negative or positive? It's a positive number, right?
Yeah, I did like that.
I would want to see art. Sí, yo también quiero ver.
So he'll know.
Ponlo en la computadora y lo escribimos. ¿Verdad?
Lo puedes hacer.
O lo que puedes hacer también es, nos lo mandan el examen y lo vamos a imprimir aquí.
I didn't do this one. I didn't do one.
My only question on the 23rd is, do we have to take second directives?
Yes.
You know.
It's the only metro area. But outside of
Yeah, they were promoted it. Yeah, something's are great when you're traveling, looking outside at like if you left the city, there was no cell reception until you got to the next city.
on the way back.
Pero pues algo, escribe algo. No, es lo que vamos a hacer. Que lo cambie. Oh, sí, eso sí.
Yeah, I don't know, like, I'm obsessed with
Bueno, voy a hacer lo
I didn't get that set.
everything else.
Oh, I never.
Yo nunca he usado ahora que tengo Android. No porque no quisiera, me daba igual. Pero ahora me gustó lo que se gustó de esta. Y a lo mejor el otro también lo tiene, pero nunca le moví. El Siri. Porque le digo, hey Siri, acuérdame de tal día a esta hora, acuérdame de hacer esto. Ajá. Y le digo, y cuando pasa ese día y la hora, y me dice, oh, me sale un recordatorio. O le digo, cuando llegue a la casa, acuérdame de sacar los botes de la basura. Y cuando llego a la casa, me avisa. Yo también sé que yo también. Me encantaba, yo mi primero fue el 2.
En serio, no lo tuve. Yo tuve primero dos. Yo no, yo no tuve.
Voy al baño antes de que empiece.
They chose mine, but it just hit just right on. I think it's like right there, like at the third one right here.
Why did we just put it?
Yeah.
We always eat that's the
Consider it
money.
like, office. Yeah.
You still stop.
Right, no, it's cute.
Yeah, I think it's cool. Cause it'll like be on the morning. So it'll be off, and I'll drive by there like nobody in the fucking building. Besides and everything. And like the next week, we'll be back online. And
Yeah.
find another fucking place. Find a place I wanna buy. It's like, fucking perfect. And down the street from the VA.
We would be the small ones.
Still fine. It would be perfect.
Got a wall around it. Talking about doing shit like barbecue and stuff like that. That'd be nice, there's a lot of funny space back there. In the backyard.
Oh, nice.
I'm sorry.
I mean, now it's a whole nother level.
Close by.
Cause I know, like, back home, they
There
have businesses down below, you live upstairs.
Oh boy, folks, you still get to take your test.
I was like, no.
All right. So, what were we about to do? We were going to try this one?
Yeah.
Or did I say we'd move on?
You say you go on.
Yeah, I think so too. Because, well, let's just look at it. How would we do it? It says here, a firm produces 2 kinds of tennis balls, we sell for $250 and 4. And the total revenue is given by that. And then they have the cost, and it's given by that. And it says find the number of each ball to maximize the profit. So this is definitely worth looking at. Where can I do it? Right here. What's the formula for profit? Yeah, revenue minus cost, right? So that's how we get our profit formula. So we would just go ahead and jot down P of X equals the revenue, which was 2.5x plus 4y, minus the cost, which is x squared minus 2xy plus 2y squared. And that's the formula that you would take action on. So what is that if you distribute? Negative x squared plus 2xy minus 2y squared plus 2.5x and plus 4y. So that's it. There was just a preliminary step in which you put those two formulas together to create your own formula, but it's still going to be the same process.
Wouldn't that be on minus 4y at the very end?
These are both positive.
No, all the way at the end.
Oh, all the way at the end?
Plus negative 4y, because you take a negative all the way through. In the parentheses.
Yeah, but only these terms change their sign. Because it's minus these terms. These terms are still positive, 2.5x.
No, I know. I'm saying in your answer. After negative 2y squared plus the 25x, wouldn't it be negative 4y?
No, because this 4y is positive.
Oh, that one. You
Yeah.
already condensed it. Never mind.
Yeah, sorry, that's part of that instruction. So did that answer your question? Okay.
Mhm.
All right, so that's it. Now you would do the same process as the determinant problem, but on that formula. So it's the same process, yeah?
My question was, do we have to do the second degree derivatives on this one, since in the instructions it tells us find the number of each type to maximize the profit? So since there's only one critical point, would that automatically be the
I didn't know what the critical point is.
once you take the derivatives?
Yeah, once you take the
The
derivative.
first derivative. Do we need to do that second derivative?
Oh, because they're telling you it's maximum?
Uh-huh.
Now, Lorena's asking a really good question, folks. Because the determinant, we only do the determinant to figure out if it's a max, a min, or a saddle. And they straight up already told us that it's a maximum. So can we just kind of be like, all right, well, whatever, it's a maximum. No, I want to see you do the process.
Okay.
Yeah. Okay, then here we are, we're on the last bit, which is Lagrange. So just like I wrote the steps over here, we will write the steps down for Lagrange as well. Everybody ready? All right, so I'm going to erase all that. Okay, so I did give the formula right there on the page, but maybe it'd be helpful to write it with the lambda because I used the letter L because I didn't have a lambda. So let's start by writing the steps. So step 1, and I'll write out Lagrange right here. The first step for Lagrange was identify what?
Find G of XY.
Yeah, identify your constraint.
Oh.
Yeah, that's G of XY. Which means it has to be something equal to 0. So what is our constraint here? That x plus y has to equal 8? So we change x plus y equals 8 into moving all the terms to one side. So I'd have x plus y minus 8 equals 0. And that right there is your constraint function. So you would say g of x, y is equal to x plus y minus 8. Okay? So you take your constraint, set it equal to 0, that's your g function. Step 2 is create the Lagrange function. Create Lagrange function. And that definition was the big F as a function of x, y, and lambda, which is what? The original function minus lambda times the constraint function?
Yes.
Yeah. So that's your Lagrange function. And then in my instructions there I say set all three partials equal to 0 and solve. So once you have Lagrange, then you would set f little x of x, y, lambda equal to 0. And then set f little y of x, y, lambda equal to 0. And set f y's lambda of x, y, lambda equal to 0. Now that's going to give you three different equations that you all set to 0. And you can solve them any way you like. But what's the first thing you want to do? Is eliminate lambda. Right? Because that would be convenient. Now keep in mind that the determinant problem and the Lagrange problem, both of those are going to end up on your final exam. Right? So these are good solid problems that are going to stick with us. So what do we do first? We already have our constraint function, right? So g of x comma y is x plus y minus 8. Okay. So then our Lagrange function is f of x, y, lambda equals what?
Equals x squared plus 2y squared minus xy
Mm-hmm.
minus lambda
Lambda times.
x plus y minus 8.
All right. And we should go ahead and distribute the lambda to make it look good. So it's x squared plus 2y squared minus xy minus lambda x minus lambda y plus 8 lambda. Okay. So that's our Lagrange function. So now what do we do?
Find the derivatives and set them equal to 0.
Yeah, find all three partials. So my partial for x is, let's see, Julie, what's the derivative with respect to x?
2x
2x,
0 minus y
yeah, minus 1y,
minus 1 lambda.
yeah, minus 1 lambda. And the rest of those mean nothing. Okay, and then Shemaya, what's my partial with respect to y? Yeah, 4y
1
minus 1x, 0, yeah, minus lambda. And then what's my derivative with respect to lambda? Now there, to do the derivative with respect to lambda, remember if you take the derivative with respect to this lambda, you're just going to get this back again, but with a minus sign in front of it. So the derivative with respect to lambda is just going to be negative x minus y plus 8. Which is indeed just the opposite of the constraint function. It's always going to be the case. Okay, so we have all three of those. We set them all equal to 0. And we now have our three equations that we're going to solve. Well, what's the first thing we're going to do?
Eliminate lambda.
Eliminate lambda. Because that's just a dummy variable that we need to get rid of. Personally, I would use elimination. I think elimination is a really clean solution for this. So I'm going to keep this equation, 2x minus 1y minus lambda equals 0. But then what will I do to this equation?
Negative.
Multiply by negative 1. So that'd be positive 1x, negative 4y, positive lambda. And that way my lambdas cancel out and I get 3x minus 5y equals 0. So now that's one equation, and I can use it with this equation. And again, now there you can solve it any way you like. You can plug it into your calculator and do a determinant. Shemai, what do you think? Right, what did you see that part?
Yeah.
Is that okay? Okay, yeah. Yeah, that's probably what I do. So now I take this one, and I want to move the x and y to the other side, so I just have x plus y equals 8. And now I just have there of 3, negative 5, 1, and 1. And another, my B matrix is 0, 8. Did I do that right? Yeah, and then you can plug it in and use the matrix. How's that?
If our numbers are not nice like that, they're always gonna.
What?
If our numbers are always nice, they're always talking to matrix.
Yeah. Or you can just solve this, using elimination or substitution or whatever you want to do. But I think A inverse B would be pretty handy. All right. Well, folks, I think that was an hour, wasn't it?
Yep.
Yeah, sure was. That was an hour. So I am going to keep the steps up there. And I think that's all I need to keep up there, right? Just the determinant and the Lagrange? Is that fair?
Yes.
Yeah. Now, what I want to collect from you folks, which I'd like to collect first, is all 3 notes packets. So if you would, please stack them in order, 1, 2, 17, and put your name on them. Oh, I don't need the determinant or the derivative review. I don't need the slope packet or the system packet. Just chapters 1, 2, 17, and then the practice test. And if you'd stack them all in that order, that'd be great. So chapter 1 through 17, and then the practice test. Yeah, right up here. And I'm gonna alternate stacking. Okay, Nick, is that all of them? Yes. All right.
Oh, I put both.
Well, that's okay. We'll just separate them out.
There you go.
That's one of them. That's one of them. Okay. And that one. Great. Thank you, Daisy. If everybody wants to reload on snacks, I think there are more snacks back there. Carter, I'll take yours then. And then practice test. Okay, great. And then the other ones. You did? Where did? Oh, there they are. They're right there. Okay.
Is there any questions on the exam or?
Yeah, we get exactly. What else do I need? Oh, Lorena. Okay. Now, technically, folks, we should all take our break right now because, so that way you have a chance to go use the bathroom, whatever you want to do. It's 6:37. Let's be back in here at 6:45-ish. And then we can all start together and everybody can take a little break right now. No one needs a calculator?
My chapter 2 has like pages.
Oh yeah, that's fine. Thanks.
Put us to work this past weekend.
You what?
You put us to work this past weekend.
I did? Well, I hope it paid off.
I hope it paid off.
Yeah, I think it did. Yeah, you're so honest.
Yeah, I was a minute late. They're so good.
Wow, these bars look great. Chewy, not buttered, or what?
Why not both?
Well, I want to make sure everybody else gets theirs. I don't even deserve one.
Everybody deserves a snack.
Ah, well, that's true.
We've all had a long day.
Yeah, that's absolutely true. What time did you guys all start your morning?
10.
10?
I have to be like at 4:30.
Oh my gosh.
I tell my school to wake up.